where we go with the angle of deflection. So there are two ways of looking at the angle of deflection. The first one is if the angle after the collision is less than 90 degrees. The angle of deflection there is the angle theta. So how you'd work it out is you'd get the angle after the collision, you'd have the angle before the collision, and you'd subtract the two of them to get theta. So angle of deflection is the angle of the sphere A after the collision minus the angle of sphere A before the collision. And we can see there that the reason we use the angle before the collision is because we have vertically opposite angles there, alpha, that are marked in the diagram. Okay, the second thing you need to be aware of is if the angle after the collision is greater than 90. So if we look there at sphere A, it travels up towards the top right and it would continue along the red dotted path, but because of the collision, the I component becomes negative, so sphere A kind of rebounds back and continues on upwards, so it goes towards the top left-hand corner. Now the opposite angles here are alpha and the angle between the red dotted line and the horizontal. The angle after deflection, so that's alpha. The angle after deflection is the angle beta there. So you'd get tan of beta is equal to the j component over the positive version of the I component after the collision. And then the deflected angle is the angle there that's unmarked, but is now called theta. And in that case, b plus theta plus alpha equals 180 degrees. So you need to be aware of whether the particle rebounds with an angle after the collision less than or greater than 90 degrees. Or you need to be aware of whether the I component after the collision is positive or negative.